Good morning to one and all present here. My name is Bharat and my partner name is Karthikeyan. We both are from EC department. So our project is a traffic monitoring system. We know that traffic congestion is one of the major problems in today's world. Let's say that in a four-way road there are four signals and the time allocated for each side of the road is the signal is just 60 seconds. Let's assume that on one side of the road there are hundreds of vehicles, but on the remaining side there are only 10 to 20 vehicles. These 10 to 20 vehicles can easily cross the signal within 20 to 30 seconds. So the remaining amount of time is getting wasted. So our project basically focuses on reducing the wastage of time by changing the signals timing. We use the concepts of image processing and machine learning in order to reduce the signal time. So moving on to image processing. So here we fix a camera on the signal and identify the number of vehicles on each side of the road by taking a picture of all the four sides of the road. We send this picture to the server, which in turn, after performing all the algorithms, returns the sufficient signal time for each side of the road. Here, the classes and the number of vehicles have been identified. The class of an vehicle has been identified by an algorithm called Yolo Algorithm. YOLO means you only look once. It is an machine learning algorithm used to detect the class of an object and their bounding box in a fast and an accurate manner. YOLO doesn't search for particular objects in an input image. Instead, it splits the images into cells and it determines the probability that the particular cell contains a certain class. And finally, the class with the maximum probability is chosen. So the usage of our project is first thing is lesser fewer consumption. As we know that as the waiting time in the signal is getting reduced, fuel consumption is really less, and time and money are saved. And the next thing is our project could learn and adapt to the traffic pattern. Let's say that during 8 a.m. in the morning there is lots of vehicles passing by the signal, whereas during the night time at around 10 p.m. their number of vehicles passing the signal will be really less. This traffic pattern will be recognized by a thing called reinforcement learning. Reinforcement learning is an area of machine learning concerned with how intelligent agents ought to take actions in an environment in order to maximize the notion of cumulative reward. Basically, it's based on concepts called state, action, and reward. So we kind of reward it to reduce the traffic time. So given enough time, it reduces the traffic signal time by learning the seasonal or compute patterns. And the next usage is it's versatile. Our project is versatile because the packages we have used here are modular packages. In future, if you want to make some changes or anyone can modify it easily, as all the packages are separate packages. So the packages that we have used in this project and the final demonstration will be explained by my friend Karthikeyan.
In our project, we have a central Node.js server that serves the state of the traffic light. The traffic lights can read the data of the server and act accordingly. Firstly, we read the camera input and feed it to the Yolo V3 algorithm, and then take out the number of vehicles on each street from the algorithm and then feed it to the DQN agent. The deep Q network is able to determine the actions that should be taken in order to reduce the traffic time and get the best results out of the system. Then it feeds the state of the traffic lights to the server where it is hosted for the traffic lights to read from. We went with YOLO v3 because it is precise and we were comfortable with it. It was extremely easy to work with and gave much better results than when we tried our custom solutions. The Yolo V3 algorithm is available in a variety of configurations depending on the processing power. Thus, it stands with our ideal to build a truly scalable system. Regarding the architecture, we initially tried out PPO and DQN, but found that deep queue network with experience replay gave better results in our case. But due to the modularity of the system, the architecture can be easily modified if needed. The observed state here is the current state of the traffic lights and the number of vehicles. The action space consists of all the possible permutations of the traffic lights that are allowed. The reward here is the negative of average of travel time. Most of the time spent in the project went into debugging the reinforcement learning agent and tuning the hyperparameters. Our system is extremely versatile, so it can run on any platform and both the popular Sumo and CityFlow simulators. Sumo itself is extremely powerful and can be used to simulate large and complex environments. We can see that our simulations are working. Due to the current circumstances, hardware realization of our project was delayed. Thus, we see that the RL agent is able to control the environment and yield positive results.
So let's talk about the disadvantages of a project. So the first thing is it is hard to identify vehicles during night time. That is after sunset or after sunset, our traffic monitoring system doesn't work up to the expectations due to the lower light conditions during the night time. In that case, we could install some night vision cameras to keep the dynamic system working as it works during the daytime. And the second disadvantage is it can't detect emergency vehicle, that is, or the proposed model does not distinguish normal vehicles with some emergency vehicles like ambulance, fire brigades, etc. So there is no priority given to these vehicles. And let's talk about the future scope of this project. The first thing is we can use infrared cameras to clearly identify the vehicles during the night time. That is, by applying some suitable image processing methods, we can enable the system to control the traffic effectively during the night time also. And the second thing is we have to find some way to identify the emergency vehicles like ambulances and fire brigades so that it can pass as soon as possible, as because providing priority to such vehicles will save a lot of lives and properties. So that is it, and I would like to thank Robotics Club for giving us this wonderful opportunity. Thank you so much.